Good morning. Meghna KS. Please turn on the video. Vijay SK, yourself as well. Okay. Once again, good morning, everybody. Welcome to Pi Academy, the place for mathematics and science. Dear students, in today's class, we are going to commence second chapter in science, particularly in chemistry. And before going to that chapter, just let me give you some of the situation where we go for using some of the chemical compounds. You are very familiar with the substances which contain chemicals. In general, we can say that what are the things we see? All are chemicals only. But some are particular, like when we go for using the food items, and we will go for liking them based on their taste. And that, could you tell what are the tastes that you go for experiencing? You may go for
sugar,
sour in taste, or bitter in taste, or some are very sweet. Is it not? Some are pungent and some are spicy. So it is all because of the chemicals that are present in those food items. Let me take few examples for them. Like you go for taking a piece of lemon and you go for squeezing it to extract the juice. Have you ever tasted the juice of lemon directly? Yes. Then what taste you will experience? Taste. Sour in taste. Similarly, have you tasted the soap powder or else soap? Sometimes it happens by taking the bath, and sometimes we'll go for just it may enter into your mouth, then you feel, or you will have an experience of a taste. What is the taste? It is
bitter
in taste. Similarly, you might have also experienced to taste the quicklime. Which is that? Calcium oxide. Quicklime. Or else the milk of magnesia. What is the taste that you experience when you go for just tasting it? That is also bitter. And unripened the fruits like the grapes, even mango, they're all sour in taste. It is all because of the chemical compound present in them. Let me take some of the examples for the fruits having sour in taste, like lemon, as I said. Similarly, orange, then
grapes, apple,
grapes, many are there. Similarly, some of the items which are bitter in taste, as I said, the soap solution or soap powder, then alkaline that is present in the battery. The solution that is present in the battery, that is also bitter in taste. And as I said, the milk of magnesia, which is used as an antacid. It is one of the antacid, right? It is also bitter in taste. Then the same way,
calcium oxide,
quicklime, it is also bitter in taste. As I said, that the taste, it is because of the chemical compounds that are present in them. I'll go for taking with the very most familiar one. It is lemon. Could you tell the chemical compound that is present in the lemon?
Citric acid.
Citric acid will be there. Orange?
Citric acid.
Citric acid will be present in that. Similarly, grapes? Tartaric acid will be present. And in the same way, I'll go for taking even the milk. Could you tell chemical compound that is present in the milk?
Lactic acid.
Lactic acid.
Lactic acid. Whereas in soap, the chemical compound that is present in the soap. Yes, very good. It is sodium hydroxide. The milk of magnesium, which you are very familiar.
Magnesium hydroxide.
Magnesium hydroxide, MgOH twice. The quicklime.
Calcium oxide.
Calcium
Calcium
oxide.
oxide.
And could you tell the compound which is used for whitewashing? For whitewashing.
Calcium hydroxide.
Calcium hydroxide.
It is calcium hydroxide solution. So these are some of the compounds present in some items. Because of them, we experience the bitter taste. And you can also notice that the chemical compounds which are responsible for sour taste, there are acids. And the chemical substances which are responsible for bitter in taste, there are bases, right? And the combination of these, like I may go for taking sodium hydroxide, it is a base, and I'll go for taking an acid, HCl. The reaction between these two will produce a compound called the common salt that we use. It is sodium chloride. And water. Even we are also very familiar with this chemical reaction, which is also called acid-base reaction. So here we have got a salt that is sodium chloride. Likewise, many salts are formed by acids and bases. See, that is the relationship among acid, base, and salt. What is that? What is that? It is acid-base reaction, nothing but neutralization reaction. So there you can come to know an acid reacts with a
base is equal to salt plus water.
Produce the salt. Another compound, it is water. Followed. Here in chemistry, we are going to commence the second chapter, which is related to the chemical compounds which are responsible for foreign taste, called acids. Chemical compounds which are responsible for bitter in taste, bases, and the chemical compounds which are formed by the reaction between acids and bases, called salts. So this is the chapter which we are going to discuss in detail. Very nice chapter it is. Acids, bases, and salts. Now please go for writing the name of the chapter. Then afterwards, I'll go for explaining. Please do follow the regular pattern. Your notebook, you have margins, vertical and horizontal. Margins are there. Then just here, draw a line with scale and pencil. Then leaving 3 lines, again draw a line with scale and pencil. And here also. Over. Next, here make 3 columns. This is first one and it's second one. Then third one. First column, it is meant for writing the name of the chapter. Sorry, chapter number. Then chapter name, and here third column. Write today's date. Chapter number is 2. It is second in chemistry. Name of the chapter, you write here. Acids, bases, and salts. And write today's date. It is 17/8/2020. Written up? Huh? How does it look? What? Frame? 17/8/2021.
Everyone must turn on your video. Everyone must turn on your video.
Now, let's go for discussing the board. Acids, bases, and some in detail. Before that, we must need to have the basic information regarding these compounds: acids, bases, and salts. Please don't go for writing anything. Listen to me first. Afterwards, you may go for writing. Here, one thing we have to know that acids are sour in taste. In general, we can say that the compounds having chemical compounds having sour in taste, they're all acids. It is one of the just property only. Then what other property it has to satisfy to say the compound as an acid?
Which produces H plus ion.
Right. Okay, that is also property. Then how do you go for defining an acid? Very good. Very good. Here, as you are very familiar with some acids like HCl. What is this?
Hydrochloric acid.
Hydrochloric acid.
H2SO4. Sulfuric
Sulfuric acid.
NH4OH.
Ammonium hydroxide.
Ammonium hydroxide.
Is it acid?
Base.
Base.
Base, sir.
We have HNO3.
Nitric acid.
Nitric acid.
Could you name the acid which is present in the vinegar used as one of
Acetic
the
acid.
ingredients in the food item?
Acetic acid.
Acetic acid.
Acetic acid.
Acetic acid, CH3, COOH. When ant bites us, then we feel irritation in that place.
Formic acid.
It is because of one of the acid produced or injected by the ant into our skin.
Formic
What is the
acid.
acid? It is formic acid. Formula?
HCOOH.
H. Formic acid. Similar. You are also very familiar with one of the weak acid which is present in the atmosphere formed by sulfur dioxide and water vapors. Yes, it is H2SO3 called
Sulfurous acid.
Sulfurous acid.
Sulfurous acid. H2SO4 is sulfuric acid. H2SO3 is sulfurous acid. Similarly, again, one of the weak acid present in the atmosphere which is formed by the reaction between carbon dioxide and water vapors. Very good. It is carbonic acid. Here, carbonic acid formula H2CO3. Then the acid which is present in the lemon.
Citric acid.
Citric acid. Then could you tell the chemical formula? It is
C6H8O7.
It is the chemical formula of citric acid. And we also know that the acid which is present in the milk.
Lactic acid. Lactic acid.
Lactic acid.
Acid.
Formula C3H6O3, right? So these are all some of the acid. And one of the important property that we can see in all the acids is if these acids are dissolved in water. I'm not telling that reaction. When these are dissolved in water, they produce hydrogen ion. You take some amount of HCl and it is to be added in the water and it will produce hydrogen ion. Similarly, H2SO4, when it is dissolved in water, it produces hydrogen ion. HNO3, when it is dissolved in water, it produces hydrogen ions. It is one of the important property of all the acids. In general, acids, they produce hydrogen ion when they are dissolved in water. Hence, we define the acids as these are the chemical substances which are sour in taste and produces hydrogen ion on dissolving in water. Clear? Once I repeat, the chemical substances which are sour in taste and produce the hydrogen ion on dissolving in water are called acids. Followed? Then, as the basic information, just I'll go for giving you the properties of the acids which describe the acids without changing their identity. What do you call such properties? What do you call the properties which describe the substance,
Physical
material, or compound without changing their identity? They are called physical properties. Just we shall recall some of the important physical properties. Physical properties, which you are very familiar with, Then what are those physical properties?
State.
We all know that, obviously. What is the taste of the acids?
Sour in taste.
Sour in
Items
taste.
which contain acid. They are all sour in taste. Then we also know that when in the acids, if you just go for dipping the litmus paper, if
It
it is
becomes blue litmus paper red to red.
It turns
right,
blue litmus
if
to
it
red.
is red litmus paper,
Doesn't change, sir.
It remains red.
It is base, sir.
dark aguste. Got it? So all the acids will turn blue litmus to red. Then similarly, as I said, these acids have a capability of producing the hydrogen ions on dissolving in water. Andre ions ide andre, do they act as electrolytes?
Yes, sir.
What are electrolytes?
They supply with conduct
These are
electricity.
the liquids. Electrolytes are the liquids which allow the current to pass through them. Even now, solids are the conductor of the use one. The material which allows the electric current to pass through them, they are all conductors. Even the liquids which allow the electric current to pass through them, they are called electrolytes.
Electrolytes.
All the acids,
Conductor.
whether it will be weak acid or strong acid, they all conduct electricity. Hello, this is some general information. Now coming to the bases. Yes. And okay, coming to bases. We all know that bases are in what taste?
Sour to taste.
Bitter.
Bitter.
Bitter taste.
Bitter in taste.
The bases which we are very familiar. Yes. Most familiar one. It is
Sodium hydroxide.
sodium hydroxide.
Calcium hydroxide.
Yes, which is used for whitewashing. Calcium hydroxide, CaOH twice. What is the common name of calcium hydroxide?
Slake lime.
Flake lime. Then milk
Calcium
of
oxide.
Mg, OH,
Magnesium hydroxide.
Magnesium hydroxide.
Potassium hydroxide.
yes, potassium hydroxide. It is KOA. Aluminum hydroxide. Huh?
AlOH.
OH thrice. AlOH thrice. And another one. Ammonium hydroxide.
NH4.
NH4OH.
OH. These are few examples for bases. They are bitter in taste. And another important property is when these are dissolved in water, water ಏನಾದರೂ dissolve ಆಯ್ತು all these will
OH
produce
minus.
OH minus.
Hydroxide, sir.
wait,
Hydroxide ions.
which is called hydroxide ion. Hydroxide ion. Similarly, when calcium hydroxide is dissolved in water, it produces the ion called again OH, hydroxide ion. Magnesium hydroxide, when it is dissolved in water, produces hydroxide ion. This is the common property that we can observe in all the bases. And based on this, we can go for defining the bases as the chemical substances which are bitter in taste and produce hydroxide ion on dissolving in water. Clear? And
Red litmus blue, sir.
H plus is what type of ion? What do you call the positively charged ion?
Cation.
Anion. Acids will produce the cation called H plus and bases will produce an anion called
OH minus.
OH minus. Now let us come to know some of the physical properties of bases. Then
Bitter to taste.
They are bitter in taste.
Bitter in
taste. They produce
litmus.
water. Then what happens when litmus paper is dipped into the base?
Red to blue.
Red to blue.
to blue.
It turns blue. If it is blue,
It remains same.
Remains same.
Acid.
there will be no change in the color, but it becomes dark blue. There will be no change in the color. When red litmus paper is dipped into the base, it turns blue color. Now you tell whether the bases conduct electricity.
Conduct
electricity.
Conductor.
Okay, they have a capability of producing the ion, which are responsible for conducting the electricity. Hence, bases are also called
Electrolysis.
electrolytes. That means they conduct electricity. Followed? Yes. Now, come across the combination or the reaction between an acid and base. Yes, it is. A compound that is formed is
salt.
salt. Then what is the taste of the salt? It is salty in taste. It's a chemical compound which is salty in taste and formed by the reaction between an acid and base. Let's go for taking few examples for salts like
Sodium chloride.
very good. Sodium chloride,
Copper sulfate.
Sodium sulfate.
MgCl2.
You are very familiar with the periodic table. You may not remember all the elements, but some elements are very familiar. In one of the group in the periodic table consists of the elements which are the elements present in the most of the salts. What are those? Also called the 17th group. They are called halogens. Fluorine, chlorine, bromine, iodine, astatine. NP-dena? Yes or no?
Yes,
Have
sir.
you heard about chlorine?
Yes, sir.
Chlorine,
Yes, sir.
iodine, like that. See that. Here, sodium chloride, potassium chloride, magnesium chloride, magnesium iodide, potassium iodide, PbI2.
MgCl2, sir.
Even some,
Magnesium chloride.
wait. Magnesium sulfate, MgSO4. Potassium sulfate, KSO4. Sorry, K2, SO4. Aluminium sulfate, A2, SO4. Twice.
MgCl2 magnesium chloride.
The salt. Then could you
Silver nitrate.
could you tell the acid and base from which the salt called sodium chloride is formed? Yes. Base is sodium hydroxide and
Chlorine.
acid is
HCl.
HCl.
Hydrochloric acid.
next. Here, KCl. Potassium chloride is formed by the acid called
Potassium hydroxide.
HCl.
base is called potassium hydroxide.
Potassium hydroxide.
Name the base from which magnesium chloride is formed.
Magnesium oxide.
Magnesium
Magnesium hydroxide.
oxide.
And acid? Hydrochloric acid.
Hydrochloric acid.
Hydrochloric acid.
Similarly, aluminum sulfate is formed by the base called
Aluminium hydroxide.
OH thrice.
Thrice.
And the acid called
Sulfuric acid.
Sulfuric acid.
sulfuric acid. Then, what are the physical properties? They are obviously salt in taste, and they are formed by the reaction between an acid and base.
Acid and base.
Next, another one. What about their action with litmus paper?
No
No
change, sir.
change.
Yes, no reaction at all. Yakandre salts are neutral
Neutral
compounds.
solution.
Salts are neutral compounds. Then you tell that whether salts are good conductor of electricity.
Yes, sir.
No, but they conduct electricity
In aqueous
when they
solution.
are in aqueous form. Andre, when salts are dissolved in water, they produce the respective ions called cations and anions, which are responsible for conducting the electricity. Hence, we say that salts conduct electricity only in
Aqueous.
aqueous form. Aqueous form alli idda matra electricity na conduct ಮಾಡುತ್ತೆ. Example, sodium chloride, it is to be dissolved in water. We get a solution called sodium chloride solution, NaCl solution. This is an electrolyte. When this sodium chloride is dissolved in water, immediately it gets dissociated into its respective ions. That is Na plus and Cl minus. Ions separate agudadu. And these ions will conduct the electricity. Followed? This is some basic information regarding acids, bases, and salts. Now we'll move on to the particular information. Before that, we'll go for writing the same. Right. First side reading. Side reading. Acids. Acids. Write the definition. A chemical substance which is sour in taste and produces hydrogen ion, H plus hydrogen ion, on dissolving in water. On dissolving, just go on recalling the definition while writing. A chemical substance which is sour in taste and produces hydrogen ion on dissolving in water is called an acid. You may give some examples for the acids, just and go for writing the chemical formula, which are most familiar to us. One is HCl, that is hydrochloric.
Hydrochloric acid.
Second one, it is H2SO4, that is sulfuric
Sulfurous
acid.
acid.
Sulfuric. Next, HNO3. This is
Nitric acid.
nitric acid.
Nitric acid.
Then CH3, COOH, which is
Acetic acid.
Acetic acid.
acetic acid. HCOOH, which is
Formic acid.
formic acid. Formic acid. H2SO3.
Sulfurous acid.
Sulfurous acid.
acid. Please recall the names of these acids. I'm just giving you the examples for the acids which we are going to use in this chapter. Sulfurous acid. Then H2CO3. This is carbonic acid. Carbonic acid. Now, just go for writing the physical properties of acids. Physical properties of acids. Right, one by one. First one is, what is the taste of acids?
Torrent
Chlorine
taste.
taste.
Yes. They have sour taste. Next, we all know that they produce
H plus ion.
H plus ions on dissolving in water. Next,
They change the blue litmus to red.
yes,
Yes.
they turn blue litmus to red. Next,
It conducts electricity.
yes, they conduct electricity as they are in liquid form. They are also called electrolytes. They conduct electricity. In bracket, you write they are all electrolytes. Next, write about bases. Right. Bases. Right. Definition. Almost it is same, except few words. Say a chemical substance
A
which is
Which is
bitter
taste
taste.
and
They produce the ions OH
oxide
minus
ion
OH minus
dissolved
ions.
in water.
in the water is called an base.
Correct. Please go on writing, recalling the definition and write. A chemical substance. A chemical substance which is bitter in taste. Bitter in taste and produces hydroxide ion. Hydroxide ion, in bracket you may write OH minus when it is dissolved in water. That is right, on dissolving in water. Right, is called a base. Right, few examples. The important bases, they are, one is NaOH, sodium hydroxide. Second one, potassium hydroxide, that is KOH. Third one, magnesium hydroxide, MgOH twice. Fourth one.
Calcium hydroxide.
CaOH twice. One more. Ammonium hydroxide. NH4.
OH.
OH. Excellent. Let's write physical properties. Right. Physical properties of bases. Physical properties of bases. Same one. What is the taste of bases?
Bitter to taste.
Bitter in taste.
They have bitter taste and they are soapy to touch. That means they are very soft. When you go for holding them, you feel that it is slippery. Right? It is. They have bitter taste and they are soapy to touch. They produce
OH minus ions.
yes, OH minus ions.
They turn red litmus
They
to blue.
turn red litmus to blue. They turn red litmus to blue. Even
They conduct electricity.
Electricity as they produce ions and dissolving in water. Right. They conduct electricity. They conduct electricity. In bracket you may write they are electrolytes. They are electrolytes. Let's write about salt.
Excuse me, Raju sir. Excuse me, Raju sir.
Yes, sir.
Sir, last 5 minutes I am giving to students, sir. They are not ready to turn on their video. Still more students are there. Last 5 minutes, sir. I am going to remove them from the meeting, sir.
Yeah.
And those students, they turned on their video and they kept their mobile somewhere. Student face is not visible. Those students also can remove from the meeting. Please
Sure,
note down the students. Sir, continue, sir.
Right. Right about salts. Even salts are also chemical substance. And they are salty in taste and they are formed by the reaction between
Acid and base.
Right about it. Chemical substance which is formed by the reaction between an acid and a base is called salt. A chemical substance which is formed by the reaction between an acid and a base is called a salt. Let us take a few important salts.
Sodium chloride.
Yeah, it is most familiar to us. Sodium chloride. Could you name the salt whose common name is
Rock salt.
baking soda?
Iodine.
Baking soda.
Sodium
bicarbonate.
Sodium
Sodium
hydroxide.
bicarbonate. Then washing soda.
Sodium carbonate.
Sodium carbonate.
Sodium carbonate. Na2. CO3. The salt which is sky blue in color.
Copper.
Copper sulfate. CuSO4. The salt which is pale green color.
Ferrous sulfate.
Yes, FeSO4, iron sulfate, ferrous sulfate, a salt, which is commonly known as bleaching powder. Yes, calcium oxychloride, CaO, Cl2. Please do remember all this. These are the important salts. Now let us write physical property. Physical property. What are these physical properties? They are salty in taste. They have salty taste. And we know that they are formed by acids and bases. They are formed by acids and bases. Do they release the ions?
No.
No, sir.
Dissolving in water. Yes, they produce their respective ions on dissolving in water. Example thought, right? Sodium chloride, when it is dissolved in water, name the ions that are formed. Na plus, Cl minus.
Cl minus.
Copper sulfate is dissolved in water. The ions that are produced are Cu2 plus and SO4 2 minus. Then iron sulfate. When it is dissolved in water, it produces the respective ions called Fe2 plus and
Fe2 plus.
SO4
2 minus.
Followed. Sodium carbonate, Na1 plus
1 plus CO3 2.
2 minus.
CO3 2.
Sodium bicarbonate,
Na 1 plus HCO3 1
Na2
minus.
plus HCO3 2.
Na 1 plus HCO3 1 minus.
Na plus HCO3 1 minus. Followed. Then calcium oxychloride, Ca2 plus OCl 1 minus. Got it? So these are the ions that are produced when they are dissolved in water. So we can write they release their respective ions. Their respective ions in water. Then whether the salts conduct electricity? Yes, of course.
Sir.
In
Aqueous solution.
yes, right. They conduct electricity in their aqueous form. In bracket you can write they are electrolytes. Means salt solutions are electrolyte. Salts are not electrolytes. Salt solutions are electrolytes.
Sir, what is the third point, sir?
They release their respective ions in water.
Okay,
They
sir.
release their respective ions in water. Example cable. Name the ions that are formed when iron sulfate is dissolved in water. MCQ na cable. What do you write? Fe2 plus and SO4 minus. But new iron and sulfate. Iron and sulfate. Sodium and carbonate. You must write their symbolic form. Sodium carbonate, when it is dissolved in water, it produces the ions called sodium ion in bracket Na1 plus. Then carbonate ion, it is CO3 2 2 minus. Or not?
Sir,
Yes.
sir, bases are bad conductors of heat, electricity, no, sir.
Say they are bad conductors. If they are bad conductors, obviously they should not allow the electric current to pass through them. They produce the ions. If the ions are not there, then you can say that they are bad conductors. And we all know that ions are responsible for conducting the electricity. Hence, bases are, even bases are also electrolytes. Got it?
Yes, sir.
Understood?
Yes, sir.
Okay. Now, listen. Please stop your activities and you have to listen my explanations. Now, we are moving to the next part of this chapter. In this part, think that some chemical substances or some chemical compounds are given to you. In that, some are acids, some are bases. Then how do you go for identifying these are only acids, these are only bases?
Indicators.
Will you go for
By
tasting
indicators.
everything?
By
Some
indicators.
can be tasted, but everything cannot be tasted. Alva. It is not a suitable method. So that is why we will go for using some other chemical substances to know whether the given compound is acid or base. And we call such chemical substance as an indicator. Indicator, it is nothing but a dye. When it is used in the acid or base, they change their color. You are very familiar with the indicator called litmus. Alva, what is the actual color of litmus? It is purple. Purple color.
Purple.
But when it is used in the acid, new acid immediately it turns
Blue to red.
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 It is used in base.
Red
It
to
is
blue.
blue. Turns blue, right? Like that. Not only that, even in some of the chemical substances are there. When they are used in acids or base, with their odor, with their smell, we can identify whether it is an acid or base. Got it? They're all indicators. They're all indicators. Indicators are the chemical substances which are used to test whether the given compound is an acid or base. You can also define this as indicator is a dye. It is a chemical substance. When it is used in the acid or base, they change their color. Clear? A chemical substance or dye which changes its color when it is used in an acid or base is called an indicator. So, with respect to indicators, we have some more information. Let me tell you that. You are very familiar with the turmeric powder. Is it a chemical substance?
No,
Of course,
sir.
it is
Natural
also
indicator.
a chemical substance. Have you ever observed what happens when it is used in the soap solution?
It turns red. Turns red.
It turns red.
Or else, suppose in most of the food item we'll go for using this turmeric powder. When that accidentally its stain has fallen on the cloth, and when you are washing the cloth with the soap powder, soap solution, you'll come to know that the red color liquid is coming out. It is because of the turmeric present. That is turmeric. It is a dye. It is an indicator. Whereas soap solution which contains the base called sodium hydroxide. This turmeric can be used for testing the given compound is base or not. In the same way, and whatever the litmus you told, Litmus is also an indicator. How it is obtained? It is obtained from a plant called
Litmus.
Not only that, even some other substances can also be used, like red cabbage. Red cabbage can be used for testing the given compound is acid or base. And even some flowers of some of the petals of some of the flowers like hydrangea, petunia, and geranium. These can also be used as indicators. See that these are available in nature only. Hence, they are called natural indicators. The indicators that are available in nature, which can be used for testing the acid or base, are called
Natural indicators.
Give some examples. Same examples on it. Turmeric.
Turmeric.
Yes. Red cabbage. Litmus. Then petals of flowers like hydrangea. Then petunia. And geranium. So these are the flowers belonging to a division of plant called Halophyta, right? Okay. Next, there are some indicators which are synthesized in the laboratory, which are prepared in the laboratory, used for testing the given compound is acid or base. Do you know what are these? These are
Artificial indicators.
Artificial indicators.
These are called synthetic indicators. The indicators that are prepared in the laboratory, are called synthetic indicators. Example for synthetic indicators. Even litmus. Litmus can be prepared. And we know that litmus is available in two forms. ನಮಗೆ paper form ಅನ್ನು prepare ಮಾಡಿದ್ವಿ, ಅದನ್ನ solution form ಅನ್ನು use ಮಾಡ್ತೀವಿ. Do you know or not?
Litmus solution.
Litmus paper ಅಂತ use ಮಾಡ್ತೀವಿ, litmus solution ಅಂತಾನೆ use ಮಾಡ್ತೀವಿ. Next, then another one.
Methyl orange.
Phenolphthalein indicator. Have you ever used?
Yes, sir.
You are very familiar with the blotting paper. Blotting paper which absorbs the solution or liquid quick as possible. Seen or not? Just it is available for 7 to 8 rupees. Scientific laboratory not siguttu. A blotting paper is usually science day nalli use ಮಾಡಿರ್ತೀವಿ. And you will go for using the indicator called the phenolphthalein. What is the color of the phenolphthalein indicator? It is colorless.
Colorless in acid, pink in base.
You go for using that phenolphthalein indicator and you write something else. ನಾನು ಏನೋ ಬರ್ದಿದ್ದೀನಪ್ಪ ಅಂತ. Can you tell? Can you see that? No.
No, sir.
It is a blank paper also. Then you will go for taking a soap solution and just go for spraying that soap solution on that. Pink color, that letter is C. Red color, pink color. Got it? Soap solution is a base. As we all know that soap solution is a base. When this soap solution is sprayed on this blotting paper, in that indicator is there. That indicator is phenolphthalein. So this phenolphthalein indicator is used for checking the given compound is base. So phenolphthalein indicator. Next, even we have one more indicator called
Methyl orange.
Methyl orange indicator. Methyl orange indicator. Next, another one, bromothymol. indicator. So litmus indicator, phenolphthalein, methyl orange, and bromothimer. And among these, litmus and phenolphthalein, these are most commonly used indicators in the laboratory. Hence, they are also called laboratory indicators. Followed?
Sir.
And there are some indicators which are also natural substances used for checking the compound is acid or base with their odor. We can come to know whether the compound is acid or base by using those substances. Following or not? Again, the substances which change their odor when they are used in acid or base, such substances or such indicators.
Olfactory.
Olfactory.
Olfactory indicators.
Yeah. Olfactory. Olfactory indicators. Once I repeat, the indicators which change their odor when they are used in acid or base are called olfactory indicators. Example, it is onion. Onion can be used for checking the given compound is acid or base. Adun matte explain martini hinge irtundi. Next,
Vanilla.
Vanilla extract. Clove oil.
Vanilla essence. So these are examples for olfactory indicators. Right? Okay. Then we have one more indicator, which is a mixture of many indicators, and from that indicator we can come to know the given compound is not only an acid or base. If it is an acid, how strong it is. If it is base, how strong it is. You know what do you call such indicator?
pH scale.
No.
Universal indicator.
Universal indicator.
A mixture of many indicators which is used for knowing the which gives the information about the strength of an acid or how strong an acid or base is. Followed? So it is universal indicator. This universal indicator will show different
pH
color
scale.
at different pH values. Other now discuss about it. pH values. Just to know this, universal indicator is also used for checking the given compound is acid or base. Not only that, even it gives us information about how strong an acid or base is. So these are 4 types of indicators. First one is natural, the indicators that are available in the nature. Next, synthetic, the indicators that are prepared in the laboratory. Olfactory, the indicators which change their odor on in acids and bases. Universal, mixture of many indicators which tells us the strength of an acid or base. Followed? Now let us come to know how can we go for using these indicators to know an acid or the given compound is acid or base. So I'll give you that information. Before that, for writing about indicators, right? So it is the indicators. Yeah, are you writing? Riya or Varnekar? Right. Indicators. The chemical substances. Which are used to test whether the given compound is the chemical substance chemical substances which are used to test whether the given compound chemical substance which is used to test whether the given compound is an acid or
base
is called an indicator. An indicator. Next, it can also be defined in another way as, what is that? A dye which changes its color or
when put in acid or base.
Acid or base is called an indicator, right? A dye which changes its color or odor when used in an acid or base is called an indicator. Indicator. So give few examples for indicators. I take litmus. Then phenolphthalein. Phenolphthalein. Then onion, etc. Well, then write types of indicators. Types of indicators. Definition in Kodana. Just I'll make you to write the types and I'll give the examples. What are those types? First one is
natural indicator.
Natural indicator.
Synthetic indicator.
Synthetic indicator.
Natural indicator. Second one, synthetic indicators.
Olfactory indicator.
Olfactory. OLFACTORY. Olfactory indicators.
Universal indicator.
Universal indicator.
Universal indicator. Over. In that, right, first one, natural indicator. Natural indicator. Let me take the examples. First one is turmeric. How do you go for using turmeric for testing an acid or base? When it is used in acid, suppose you have been given a compound and you go for taking a sample of compound in the test tube and you add some turmeric powder, even turmeric solution in that compound. If no change is observed, what do you say? It is an acid. Andre yellow color ange ittu antandre it is an acid. You have only two options. Andre namage nimge acid kottirtivi athwa base kottirtivi, not other compounds. But nimge water kotbittu test whether it is an acid or base anta helala. What is in acid there will be no change in the color. What about in case of base?
Changes in color.
Changes in red.
No change or no change in the color in case of acids, and it turns red. It turns red in case of base. I'll take second example. Even red cabbage can be used to test the given compound is acid or base. If it is acid,
No change.
No change.
No changes. No change in case of acids. Whereas a red cabbage, you'll go for extracting the juice of that, and you add few drops of red cabbage into the sample of the compound. Adenadru base agitandre immediately
It turns green.
Green color.
Green color.
Green color in case of base. Next, I'll take the litmus. Litmus, it is also a natural indicator which is obtained from the plant called lichen. What is its color? Purple. Color is
Purple color. Blue color in acid.
Right.
Red color in base.
No. You are telling in reverse order. Isn't it? It is a purple color natural indicator. That is litmus, and it is obtained from the plant called lichen. And here we have taken two compounds. One is acid and another one is base. ಈಗ ಇದರಲ್ಲಿ ನಾವೇನಾದ್ರು litmus add ಮಾಡಿದ್ರೆ what happens? Immediately turn right. If it is base,
It turns blue.
It turns blue. Blue color bantu andre the compound is base. Red color, if it turns red color, it is an acid. Got it? So right, see. It turns to red if it is acid, and turns to blue if it is base. Next, let me go for taking the synthetic indicators. Right, second one. Synthetic indicators. Synthetic indicators. So these are the indicators which are prepared in the laboratory and used for testing the given compound is acid or base. Once definition very ready. The indicators that are prepared in the laboratory to test the given compound is acid or base is called synthetic indicator. What are those synthetic indicators? Again, litmus, phenolphthalein, methyl orange, and bromothymol. But namige tumba important andre first two, which are
Phenolphthalein and methyl orange.
litmus and phenolphthalein.
Phenolphthalein and methyl.
In addition with that, we should go for writing even about methyl orange. Right. It is first one is litmus, and you all know that litmus is available in two forms. One is paper form. Second one is
Solution
form.
solution form. And the paper form only, how many colors will be there?
Two colors.
Two colors. One is red and another one is
Blue.
blue. If blue litmus paper turns red, let's see the quantity. And here is NaOH. You go for taking a blue litmus paper and it is to be dipped into the test tube containing HCl. What happens?
It becomes red.
Red color gets turned on. Got it? So if it turns red, then you can say that the compound is
Acid.
Acid.
turns red, it is acid. If it turns blue, red litmus now when it is dipped in the compound, if it turns blue, then you can say that it is base. In solution also, we have two colors. Please do remember, litmus in natural, it is a natural indicator and its actual color is purple. But ಅದನ್ನ ನಾವು laboratory prepare ಮಾಡಿದಾಗ ನಮಗೆ two colors solutions ಸಿಗುತ್ತೆ. One is red and another one is blue. If you put few drops of blue color litmus solution into the given compound, if it turns red, then you can say that it is acid. Following? Right. It is. If it turns red, it is acid.
Acid.
If it turns blue, then you can say that
Base.
it is base. Then, second one. What is that second one?
Phenolphthalein.
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 Phenolphthalein indicator. Phenolphthalein indicator. What happens when the drops of phenolphthalein indicator is used in a test tube containing
Hydrochloric acid.
ಏನಾಗುತ್ತೆ? It will be colorless only. Actual color of the phenolphthalein is colorless. When it is used in HCl, nothing but acid. Acid ಅಲ್ಲಿ ಅದನ್ನ ಏನಾದರೂ ಯೂಸ್ ಮಾಡಿದ್ರೆ it will be colorless. ಕೊಟ್ಟಿರೋ compound ಅಲ್ಲಿ, that is acid and base. If it is colorless, then you can say that it is
Acid.
Colorless. It is acid. Suppose
turns pink,
few
it is
drops
red.
of phenolphthalein indicator is added in NaOH. ಏನಾಗುತ್ತೆ?
Turns pink.
Pink color. You can say that it is base. Next, third one.
Methyl orange.
Methyl orange indicator. Listen. Just look here. Look at the board. I'm going to give you 3 test tubes containing the compounds. These are the 3 test tubes. In the first test tube, we have sodium hydroxide. Second test tube, assume that NaCl solution is alcohol, which is a neutral compound. Then here I'm going to take S2SO4. What happens when methyl orange indicator is added into the test tube containing NaOH?
It turns yellow.
Huh? Sure? Yellow color it turn agutte. If it is used in NaCl solution and ಏನಾದರೂ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ?
No change.
Orange color is. If it is used in S2SO4.
Hello.
Turns red. Red.
Red. And this is yellow. And in case of neutral solution, it is orange. So write down. Methyl orange indicator. In case of acid, it turns red. In case of base,
orange.
It turns yellow. Notes alli adu correction ಮಾಡ್ತಾರೆ. Turns yellow in case of base. Next, olfactory indicators. Third one is olfactory. This definition also ಕೇಳಿದ್ದಾರೆ. Olfactory indicator. How do you define this? The indicators which change their odor when they are used in
Acid or
and base.
called olfactory indicators. So please write the definition for this. The indicators which change their odor, means smell, change their odor when they are used in acids or bases are called olfactory indicators. Example for olfactory indicators:
onion,
Vanilla.
Vanilla,
clove oil.
But how can we use these olfactory indicators to test the given compound is acid or base? But how to go for using them? Now I'll go for
by taking extract.
Please stop writing. Let me tell you how to use onion for checking the given compound is acid or base. Assume that the compound that we have taken are one is sodium hydroxide, which is base, and another one is dilute H2SO4 called acid, sulfuric acid. Now, let me tell you how to use onion for testing these. First, you go for taking a piece of onion, and it is to be chopped into very fine particles, very small particles. Chopping. Then after that, it is to be taken in the plastic bag. Means all the pieces of onion are to be taken in a plastic bag. Take some strips of cloth, cotton cloth, some strips, and they are to be kept in the bag containing plastic bag containing small pieces of onion and mix it well. Then tie it. Then after that, keep it in the refrigerator for a day. One day under the refrigerator, then it will the strips will get the almost full smell of onion. Then after that, after a day, you just take out these strips one by one. I'll take the two strips, strip 1 and this is second, strip 2. In the first strip, just go for adding H2SO4, means put some drops of H2SO4. And here, NaOH. After that, take this strip, rinse that into the water. Followed, then remove it and go for smelling it. If the smell of onion is detected, smell of onion, smell is detected, then you can say that it is an acid. Andre idu badlagi vere yavade compound kottaga when whatever the compound is given, you just add few drops of that compound on the first strip and rinse that into the water and smell it. If the smell of onion is detected, then you can say that it is an acid. If, and similarly, for in this case, you have added few drops of NaOH on the second strip, then dip that into the water. Followed and smell it. You can come to know that smell is not detected. Smell namige gottagodilla andre it will lose the smell of onion. Followed, if no smell is detected, then you can say that it is base. The same way, vanilla essence and chloride, adanu ಏನು ಮಾಡಬೇಕು ಅಂದ್ರೆ you take a sample of the given compound in the test tube and you add some vanilla essence into this. If the smell is detected, you can say that it is acid. If no smell is detected,
it is base.
It is base. This is the way we have to use olfactory indicators to check the given compound is acid or base. I mean, they have given an activity with respect to usage of olfactory indicator called onion. Adan kodidare exam nallu kuda kelidare, and the same question has been given in my notes as well. Adike explanation kodidini, you have to go through that. Followed. Have you taken this example?
Yes, sir.
What do you write? If the smell is detected,
Acid.
it is an
Acid.
No smell is detected.
It is
Base.
base.
Detected, then you can say that it is base. Over. Definition important, you must learn this. Fourth one, it is universal indicator. Universal indicator. Fourth one, universal indicator. So even this definition can also be asked. What it is? What it is? What it is? A mixture of many indicators which gives the information or which gives the information about the strength of an acid or base, and it shows different colors at a different pH values. So write down a mixture of many indicators which show the strength of an acid or a base with different colors. It's called universal indicator. Listen, a universal indicator alle namage different colors barutte, and even the numbers are indicated The numbers will be from 0 to 14. Adana pH value ma kelbekandre niಮಗೆ detail ಆಗಿ information ಕೊಡ್ತೀನಿ. Now just I am giving you the important colors. ಇಲ್ಲಂದ್ರೆ 0 to 14 ಬರ್ಕೊಂಬಿಡಿ. 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. 0 ಇದೆಯಲ್ಲ, it is
Dark red.
dark red. Dark red here. Then it is
Red.
just red. Seventh one is important.
Green.
It is
Neutral.
green.
Neutral.
Green. Next it is 15th one. It is dark
blue. Dark blue.
blue. Just it is blue color. It is to ನೆನಪಿರ್ಬೋದು.
Sir, 14 is violet. Sir.
This is dark blue. Observe.
Sir, violet. Sir.
ನಾನು ನಂತರ ಬರೀತೀನಿ. You just ನಿಮಗೆ information ಅಷ್ಟೇ ನಾನು ಇದು ಬರ್ತಿದ್ದೀನಿ. Only to make you to understand. Very simple. In case of universal indicator, if it is red color, then we can say that acid. Under universal indicator iruttala, if that strip is to be dipped into the acid, then it shows the red color. Red, dark red, red, then light red, ಆ ರೀತಿ ಬರುತ್ತೆ. Yellow, orange, yellow, ಆ ರೀತಿ ಟರ್ನ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಅದನ್ನ ತಲೆ ಕೆಡಿಸ್ಕೋಬೇಡಿ. Now you have to focus only red color, blue color, and green color. 0 to 6 is a red color appearance irutte, which means that it is acid. Then from 8 to 14, it is blue color. Dark blue, light blue, ಆ ರೀತಿ changes ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Then it is base. They are all bases. Next, green ತೋರಿಸ್ತು ಅಂದ್ರೆ
Neutral.
Neutral.
It is neither acidic in
Acid
nature
or
or
base.
basic in
Nor
nature.
base.
Then we can say that it is neutral.
Neutral.
ಅದನ್ನ ಸಾಲ್ಟ್ ಅಂತ ಹೇಳಕ್ ಹೋಗ್ಬೇಡಿ, ಯಾಕಂದ್ರೆ ಮತ್ತೆ ಸಾಲ್ಟ್ಸ್ ಅಲ್ಲಿ ನಮಗೆ ಅಸಿಡಿಕ್ ಸಾಲ್ಟ್, ಬೇಸಿಕ್ ಸಾಲ್ಟ್ಸ್ ಅಂತ ಬರುತ್ತೆ. Just it is right, neutral. Neutral. This is one information. First, once I tell you, first information is if it is red color, the compound is acid. In the universal indicator, if it shows blue color,
Base.
it is base. Then green color, it
Neutral.
is neutral. ಆದ್ಮೇಲೆ okay, if it is dark red ಅಂತಂದ್ರೆ, then you can say that it is
Very acid.
This is strong acid. And just red,
Weak acid.
it is not weak acid. It is not stronger
6
than
comes weak acid, sir.
the dark acid. Weak acid ನಮಗೆ ಇಲ್ಲಿಂದ ಬರುತ್ತೆ.
Compared to dark acid.
Just know this. Andre, I am giving you the strength. The strength of the acid is more at 0 than 1, is more at 1 than 2, like this. Got it? Next, here, blue color and dark blue color. Dark blue ನಮಗೆ ಬಂದಿದೆ ಅಂತಂದ್ರೆ it is strong base. It is stronger than 13th one. Hello? ಅದನ್ನಷ್ಟೇ. You just know these are actually pH values, power of hydronium ion concentration. ಅದನ್ನ ಆಮೇಲೆ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಿ. Hello? If red color, which what is the chemical nature?
Acid.
Chemical
Acid.
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 If blue color,
Base.
Base.
Neutral.
Neutral.
more dark indicates it is strong
Strong
acid.
acid.
More
Strong acid.
Strong
more
base.
Strong base.
blue color indicates
Strong
it is
base.
strong.
Strong bases.
Next, we will go for discussing about the important properties of acids and bases. The properties which describe with the by changing the identities of acids and bases. What do you call them? What do you call the properties which describe
Chemical properties.
Chemical properties.
Chemical properties.
In tomorrow's class, we will discuss about chemical properties. Yeah, with this, let us stop the class. Thank you very much.
Thank you,
Bye,
sir.
sir. Thank you, sir.
Thank you, sir.
Bye, sir.